first of all, outline of this session. Basically, in most of the industries these days, we are using PLCs. PLC here is for programmable logic controllers. We use PLCs for automation in industries. Then our shift from industry 3.0 to industry 4.0. What was the difference when we shifted from industry 3.0 to 4.0? Then I will discuss PLC operation, means how PLC work and its architecture. You can say a brief idea about the operation and its architecture. Then we will have some applications related to smart automation where we can use these automation. Actually, this automation can be used in everywhere, in each and every field. So once I will just explain about this, all the participants, they can think how this can be used in their particular area, how they can use this session for automation in their particular area. That will be really interesting. Then different manufacturers are there for PLC. We will discuss some, you can say, leading manufacturers in this field. Then different programming languages. Different programming languages are there to program these PLCs, and we will take the most commonly used language, and it is very simple to use by everyone. And that language we will discuss here. And related to that language only, I will discuss 2-3 basic instructions today, so that everyone will be able to understand. Means how easy it is to learn, and how easily we can do the programming for automation. So that I will basically explain in this basic instruction session. After that, I am going to give you exposure about some softwares, software downloads and their setups. I will give you the website details where these softwares are available, and then I will just show the setup, how to set up these software. And one basic software which is very, you can say, light, and it can be easily downloaded, and it can be easily basically used on your PC. On that software, basically, all the participants, they are going to perform their task. So after that, we are going to conclude this session. So, yes, any query from any participant? So I will give at least 10 to 15 minutes after my session for queries. So please mute your mic. I request all the participants to mute your mic so that there will be no interference during the session. And after that, we will make this forum open for all the participants. If they have any query, they can go ahead with their queries. So first, PLC overview. As I told you, PLC stands for Programmable Logic Controller. And PLCs are used for automation, basically to control a process, whatever process is there on industry. And for that particular process, you should have a particular logic in your mind. So once a logic is there, or once the logic is clear to you, means what is required, what is expected by you, only then you can control a process and you can write the programming. So that is why we call it as Programmable Logic Controller. Basically, PLC is a solid state device. It is designed to operate in noisy industrial environments to perform all the logic functions. So PLCs are meant for industrial environment, or you can say noisy, dusty environment. They are rigid and they can work in these environments easily. Then some basically history of PLC. Basically, PLCs were invented in 1960 for automation in industries. Presently, PLCs are used worldwide in all type of manufacturing industries. Actually, in India, basically, PLCs came into existing in around, you can say, 1996 or 7, but their existence came in 1996. So Basically PLC time was right. It invented itself because there was a need for it, and other people had the same need. And basically, Dick Morley is the father of
अलग अलग
PLC,
कर
and PLC.
जब हम खाते हैं तो चाय नहीं पीना चाहते, हमारा मन नहीं हो तो जबरदस्ती पीते हैं।
Yes.
Sir, your microphone is muted. Rajesh, sir. Rajesh, sir, your microphone is muted.
Am I audible now?
Yes, sir, you are.
Okay. So industry 3.0 to 4.0. Is it okay now?
Sir,
Voice is coming?
yeah, voice is coming, sir. You have to share the screen again.
Okay, screen is not visible.
No, sir, it's not.
Is it fine?
Yes, sir.
Right. So basically, industry 3.0 to 4.0 shift in the second half of the 20th century, factories began incorporating automation technology and sophisticated electronic into their production processes, jump starting a period now often referred to as the third industrial revolution. And PLCs were instrumental in this change in production and a key player in the adoption of industry 3.0, for you can say key player in industrial automation. Now companies are implementing internet connected sensors, advanced data systems, and other technologies that fall under the umbrella of internet of things, a process that is considered to be the fourth industrial revolution. So basically, what is the difference between industry 3.0 and industry 4.0? Here you can see that in industry 3.0, basically it is industrial revolution using electronics and IT to achieve the further automation of manufacturing. And industry 4.0 is industrial revolution based on cyber physical systems, right? So the only difference is now in industry 3.0, automation was there, but you can perform that automation at the factory floor only, or maybe within some limited area. You can't control the process from anywhere in the world, right? So in industry 3.0, we can control the process at the factory floor, or we can control the process from our uh, supervisory control room that can be in the same building, or that can be on the same floor. So basically distance limitation was there. Now in industry 4.0, that you can say restriction is overcome. Now, with the introduction of IoT, Internet of Things, we can now control our industrial process from anywhere in the world with the help of IoT. That is the basically main difference between Industry 3.0 and 4.0. So I think it will be clear to all the participants and the difference between Industry 3.0 and 4.0. Now, here you can see that. Now the question is, will PLCs continue to be the ubiquitous part of production processes as more companies introduced cyber physical systems, or is the death of PLC imminent? Means with the introduction of Industry 4.0, or you can say cyber physical systems, whether our PLC, which was very critical, or which played a key role in industrial automation, that is going to survive, or it will be obsolete. That is the main question now from Industry 3.0 to 4.0. So answer to this, basically at the moment PLCs don't seems to be going anywhere, because they are easy to use, they are reliable, they are proven to work well, and they are precise. So removing or changing them in any significant way is unlikely in the near future, especially among small and medium-sized manufacturers, right? So additionally, many businesses would not be able to support the implementation of new control technology. So these are some reasons why PLCs are not going to to be obsolete. They are going to play their role in Industry 4.0 also. So there is a lot of skill set out there in the manufacturing industry, particularly with maintenance personnel or automation technicians, that is oriented basically, as I told you, PLCs can be programmed with different programming languages, and one of those languages is ladder logic language, and this language is very easy to understand, and any layman can work on this language, or can understand this language. So because of its simplicity, PLCs can be programming can be understood by any person on the factory floor, or by technicians, or by maintenance personnel. They can easily handle it. So another thing is, most of these technicians or maintenance personnel, they don't understand a scripted language, right? You can say language in the form of text, that will be difficult for them to understand. So that is why they are comfortable working with this ladder logic diagrams, ladder logic language, and which is commonly used for PLCs, and it is a workforce issue at that level, right? So for these reasons, there was urgent need to create an easy, inexpensive, and user-friendly way to help companies who are using PLCs. Means now we have to shift, a smooth shift is required from Industry 3.0 to 4.0, which should be easy for our manpower, and it should be not costly. So easy or smooth shift from Industry 3.0 and to 4.0 was required. So uh, here we can say that for this reason, there was urgent need to create an easy, inexpensive, and user-friendly way to help companies using PLCs without needing to replace expensive legacy system, or requiring personnel to learn a new programming language. So keeping this thing in mind, uh, you can say that this is the industrial requirement. So keeping in view the industrial requirement, Tambu created a Cosmos PLC IoT application that works for all type of industries, right? So Cosmos PLC application means now we can control our PLC from anywhere in the world with the help of this IoT, Internet of Things. So for that purpose, basically, in order to move from industry 3.0 to 4.0, the main requirement is gateway device, right? So what is that gateway? These gateways are basically internet connected devices that serve as the main connection point between the data from the PLC and the cloud and vice versa. Basically in IoT, we have to take the data from PLC, and that gateway is going to take that data, and then it will save that data in cloud. And likewise, we can take the data from cloud, and that will be done with the help of gateway between PLC and cloud, and then it will be transferred to the PLC. So that thing was required. So in order to perform this task, so many boards were developed. So and those boards were developed with the built-in Wi-Fi, and these kind of boards, they work very nicely as gateway for PLC. Means in order to make a connection between cloud and our PLC, these work as a gateway. And one such example of that is Raspberry Pi is such kind of board. It is basically used to connect one device with cloud, and it is with Wi-Fi. So such type of boards were made available in order to basically shift smoothly from industry 3.0 to 4.0 without basically investing in that industry, or without replacing the existing systems. That was the main concept behind that. So now I will just tell you the operation of PLC. Just so here you can see that in industry 3.0 it was without gateway. In industry 4.0 it is with gateway. So we have programmable logic controller, we have some input will come to this programmable logic controller, then this input, some program will be there in this controller. That program will be performed based on the change in inputs. Accordingly, your outputs will be changed. Outputs will be made on or off depending upon your inputs. So in this way, basically, it is you will with the help of this output device, you are going to control some factory floor process, and it will go to inputs again. PLC is continuously going to monitor the inputs for their change, for their on off operation. Basically, depending upon that, our output devices will be changed. And earlier it was on the factory floor, or from some supervisory room on that same factory floor or on that same building. But now with the help of this gateway, we can change each and everything from anywhere in the world, and we can control the process. We can monitor the process on the factory floor from anywhere. So that is called smart automation. Earlier automation was there. Now how it is smart? It is smart because now we can control it, we can monitor it from anywhere, and that is possible with the help of IoT only. So we can say that PLC in combination with IoT and cloud is basically your smart automation. Then as I told you, PLC architecture. In PLC you have some input interface, you have output interface, you have some processor. It can be microprocessor, it can be 8-bit, it can be 16-bit, and then you have memory, it can be RAM, ROM. Then you have programming. It can be programmed with the help of number of devices, right? And again, a gateway for basically controlling it from anywhere in the world. So if we call, we will discuss this processor unit. This processor unit is basically, as I told you, it can be 8-bit, it can be 16-bit or 32-bit microprocessor. Depending upon this microprocessor, it basically price is going to vary, and your IO device is going to vary. 8-bit microprocessor based PLCs, they will be less in cost, but the limitation will be limited number of input and output devices. You can control less number of input output devices. Likewise, 16-bit microprocessor will be costly as compared to 8-bit, but it will be less expensive as compared to 32-bit. But here more number of input and output devices can be controlled with the help of 6-bit microprocessor as compared to 8-bit. And likewise, your 32-bit microprocessor based PLC, it will be costlier as compared to 16-bit. And again, it will be able to control more number of devices, and we can connect more number of input and output devices with the PLC. So basically, this processor can make all the necessary decisions to control a process. Processor monitors the state of input, means monitor the state of input devices. That input can be anything, and it basically scans the program inside the PLC, and accordingly it controls the output device. So memory can be, there can be RAM and there can be ROM. ROM is generally basically EEPROM type of memory, which contains user logic program to operate the PLC. RAM is used for temporary storage of various data during the execution of user logic program. So here you can see that our program will be saved in EEPROM, and our data, temporary data with our instructions, that will be stored in RAM. And why we are using here EEPROM? EEPROM is your electrical erasable programmable read-only memory. It is used because one PLC can work for number of applications in any area, in any field. You can use that PLC. The only thing what you have to change the program. So that is why this EEPROM memory is used, so that we can change the program according to our application or according to our future needs. We can modify the program. That is the main concept of memory in PLC. Different kind of inputs can come to PLC, and these inputs can be from photocells or sensors. Then push buttons can be used as inputs. Then toggle switches can be used as inputs for our PLCs. By using these inputs, we can control various outputs, and those outputs can be your indicator lamps. Then motor starters can be there, then solenoid coils can be there, then your hooters or speakers. These are different kind of outputs that can be controlled with the help of PLC and those inputs. Then different devices to program the PLC. We can use laptop or mobile devices to program our PLC. We can use, this is the handheld programmer. This programmer can be used to program the PLC at factory floor. If any temporary change is required in our program, we can take this handheld programmer at the factory floor. We can change the program. Then HMI, human machine interface, again it will be there on factory floor only, and it will be installed on the factory floor. And we can it is just kind of you can say it can be touch screen kind of HMI, or it can be with buttons. So we can use them also to make various changes in our factory floor. So these are different programming devices that we can use for programming of our PLCs. Then the gateway, as I told you, this gateway is required to make a connection between our PLC and cloud. So internet connected devices that serve as the main connection point between the data from the PLC and the cloud, and vice versa. So here this is the board, Raspberry Pi board, that can be used as gateway between PLC and cloud. So basically this is very useful to make the connection, and in order to control the process from anywhere in the world. So these are four major parts of basically our smart automation. Then applications where we can use these automation, smart automation, we can use them for CNC machines, conveyors, process control, painting, assembly machines, packaging, traffic light control, lift control. These days, these PLCs are also used for automation, for home automation in medical industry, at hospitals, At so many places now we are going to use this because automation is required in each and every field. So in every field we need automation. So for that particular automation, you should have some logic in your mind, and depending upon that logic, you can easily program this PLC, and you can install that PLC in that field, and you can perform the automation. So these are some applications where we can use these PLCs. Then PLC manufacturers, some leading manufacturers are there. You can say Allen Bradley, Siemens, Merlin Garin, then Modicon, Mitsubishi, Texas. So different manufacturers are there, and every manufacturer, they are providing different kind of PLCs. And here we can say that in India, most of the industries, they are using Allen Bradley, Siemens, and some of them are also using Modicon. But you can say leader in this area are Allen Bradley and Siemens. Most of the industries, they are using Allen Bradley and Siemens PLCs. So I will give exposure about the softwares which are available to program the Allen Bradley PLCs, that I will show you. Now, programming languages. As I told you, there are a number of programming languages that can be used to program these PLCs. First one, you can say that ladder diagrams. Second one is statement list. Third one is Boolean. And out of these languages, ladder diagram are most commonly used because of their simplicity. Means anyone can understand these ladder diagram language, and they can easily use it for automation related to their area. Means you can easily use this language. We will see how easy to use it, this one. So in ladder diagram, I will discuss three instructions today, these three basic instructions, and you will see how easy it is to understand these instructions. So first instruction, these three instructions are, first is examine if closed, and we normally denote this instruction as XIC. So here XIC, you can see that examine if closed. Then the second one is examine if open, and we denote this instruction with XIO, examine if open. And the third instruction is output energize, and normally we use this instruction to make any output on or off. So this is normally used with output. So we are going to discuss the working of these three instructions today, and tomorrow we will discuss some additional basic instructions, and then we will perform some programs tomorrow. Today also I am going to take some examples using these instructions, how to use these instructions and how to program your PLC with the help of these instructions. Now I will just discuss the working of first instruction, XIC. XIC is your examine if closed instruction. So am I audible? My voice is coming?
Yes, sir, it's audible.
Right. Thank you, Sunidhi. So first instruction is XIC instruction. In this instruction, you can say that a symbol for this instruction is this one. This one first, XIC, examine if closed. And we also call this instruction as normally open. Normally open means it is just take this diagram, take it as a circuit. Basically, we have to complete this path. Once this path is complete, only then this output will be high. So this output can be any, it can be any lamp. Just take one example of lamp or fan, anything. So examine if closed. Now we are going to examine. Initially this is open. Here this path is not complete. It is open. This path is not complete. It means that your output will be low. So it means that when we are not giving anything to this instruction, when this instruction is low, off, zero, you can consider anything. Just take one example of, let us say, fan. Fan is connected with one space switch, right? that switch will work as your input on off, and your fan will work as output. With the help of this switch, you are going to make that fan on or off, right? So here off, we can say that it is 0. On means it is 1. So initially when your switch is off means switch is 0. Initially your switch is 0 and input is off, because this path is not complete. Just I am explaining this in a layman language, not trying to make it complicated for my participants. I want to make it general so that everyone can understand it. So that is why I'm not basically taking here engineering terms. I'm just making it in the layman language. So here you can see that one more thing here, this one and this one, these two lines, you can say one is ground, one is VC. See, that is engineering language, but make sure that you have to make this path complete in order to make this output high, right? Initially when this switch is off means it is 0. This path is not complete here, it is open from here. So that is why your output is low, off, your fan is off, right? Now I make the transition of this switch, I make it on. On means I will make it 1. When I make it 1, then this circuit will be complete, this path will be complete. Once this path is complete, then your output will be high. So here you can see that your output is high, right? So what you have to keep in your mind, just leave everything. I'm not basically reading these things, because with these it will be really difficult for all of you to understand. Maybe our engineering participants, they can easily understand, but for others it will be difficult. Just concentrate here. Whenever we are going to use this XIC instruction, just keep in mind, when XIC instruction is 0 or off, output is off. When it is on, output is on. So that thing you have to keep in mind. Just when it is off, output is off. When it is on, output is on, right? Next instruction is XIO. Now we are going to take this instruction. This instruction is examine if open. This instruction is also known as NC instruction. That instruction was NO, normally open. That instruction will remain open. And NC means normally closed. Normally closed means whenever you are going from edit mode to run mode, this instruction will be on. So we are going to examine this instruction when this instruction will be off. So that is why we call it examine if open. Initially it is closed. Here you can see that. Now we are going to examine this instruction when it will be open from here. So in this way you can say that when this instruction is off, 0, when it is off or 0, then your path is complete. It is already closed. This instruction is already closed. This path is complete and your output will be 1, right? So when it means that when your fan is switch is off, your fan is on. When you make this switch high or on, it means that when you are making this input 1, then it will work as open. Initially it will be closed, and when you make it 1, it will be open from here. Then your circuit will not be complete and your output will be, or your fan will be off. Here you can see that. Again, same thing. Just keep one thing in your mind. Whenever you are using NC, NC means when your input is low or off, your output will be on. When input is on, your output will be off. It is, you can say, just like NOT gate. Means opposite to your input. Input is high, output will be low. Input is low, output will be high. You have to just keep these two things in your mind. With NO, input output will remain same. In NC, input and output will be complement of each other. they will be different. So these two things you have to keep in your mind. And output instruction, a third instruction is OTE. This is nothing but this is OTE. So here you can see that OTE stands for your output energize, and normally we use this instruction. This is the symbol for OTE. So now you can see that this is the symbol for XIC instruction, that is normally open. This is the symbol for XIO instruction, that is normally closed. And this is simple output symbol. We denote it with this sign, and it is called output energize instruction. So these three basic instructions are there, and I hope now these are clear to everyone. Means in case of XIC, whatever is the input, that same will be the output. In case of XIO, output will be complement of your input. If it is 0, then it is 1. If it is 1, it is 0. Just you have to keep this thing in your mind in whole programming, nothing else. If this concept is clear, then you can easily perform the programming of PLCs, right? So these basic instructions. Now I will give you idea about the softwares. The first software is Bytronic software, right? So this software is by LADSIM, and this is a simulation software, and you can easily write your program, and you can check the logic, you can simulate your program, and you can make a program. The only limitation of this demo version is you can run it for 20 minutes. After 20 minutes, it will be, again, you have to open it, and you can't save it. That is the limitation, but still you can perform your programs. So I can so after the end of this session, I will just copy paste these links, website links, from where you can download these softwares. So first is LADSIM. Second one is basically the link. Second one is for your RS Logics. RS Logics Micro Starter. This is emulator, this is starter, and this is RS Links Classic. These three softwares are required to program Allen Bradley PLCs. Basically, Rockwell Automation, Allen Bradley PLCs are programmed by RS Logics Micro Starter. This is the software. Then RS Links is used as a communication driver between the PLC, or between the program and PLC, between the program and emulator. And RS Logic emulator is used for emulation of your program, and then you can easily view the working of your software. That I will show you. But these three softwares are heavy and take some time to download, and also they take some time for loading on your PC. You can try them later on, but I request all the participants that at least they should download this LADSIM demo version on their PCs, so that they can practice it side by side. Whenever I am going to give you the demonstration of this software, you can simultaneously you can work on that, and if you want, otherwise you can practice it later on, because we are going to use this software only for our practice session. And now I request all the participants, please download at least this software, so that you can easily work on this, and you will be you will feel confidence once you will work on this, and you will be able to write the programs using this Bytronic LADSIM software. So now, first of all, I would like to show the LatSim software, how it can be downloaded and how it can be used by the participants for their so is it visible? Now this software is visible, this window, this one. Is it coming on your screen? Any one of the participants?
Yes, sir.
This window is visible, software window, this one.
Yes, sir, visible.
Just let me know if it is not visible. I will. Okay, we are going ahead with our Google. Now Google is coming. Google window.
Yes, yes.
Right.
Yes, sir.
Now
Yes,
in
sir.
Google you have to type LatSim. Right. Then this new window will come. Download Bytronic. Then this site will come. And here you have to click the download LatSim demo. And that file will be downloaded on your PC. So here you can see that on the bottom of the screen, latsim.exe file is there. You can double click this file. You can save it in your on your PC first, and then you have to run. Is it coming on your screen? This demo.
Yes, sir.
Right. Next, I accept here. Then next. You can give any name, username, your name here. So if this error comes to you, some of the participants, they may get this message, right? In that case, I will just tell you what to do. In that case, basically you have to go to the executable file. Right? This one. So once you now this screen is visible. This
Yes, sir,
LAD
visible.
demo, you can see LAD demo is visible. This one. Right? So you have to basically download this demo version. You have to save it on your PC, and wherever it is saved, you have to go here, LatSim, right click, and right click on in case that error comes, you have to right click and you have to select this run as administrator. Is it visible to everyone? Yes, any one of participant.
Yes, sir, visible.
So you have just save the software on your PC. then right click, then run as administrator, right? So after this one, you have to start the installation. So here you can see that next. So once you do it, then that error will not come. So you have to start run as administrator. Actually, this software is already loaded on my PC. That is why it is asking for modify, repair, remove. So I am just stopping this demo here only. And I think all of you can easily download this software. I can just copy and paste this link on the chat box so that everyone can use it. I have shared it. You can check. Link is there for everyone. Yes, link is there in the chat box. Kindly confirm.
Yes, sir, we get it.
Right. So you can use this link and you just download this software and load it on your PC so that if you want, you can basically use this for your next session and you can also run programs simultaneously along with me. Next is I will just show you the so this is for your RS Logic software. How to download this software from website? Just please tell me if it is not visible. Again, that window. This window is visible.
Yes, sir.
Yes, sir.
Now you have to type here ab.com on your window. Then Alan Bradley window will come. Here you can see that. So in Alan Bradley, go to Sport. So you have to basically install 3 softwares now. As I told you, RS Logic Starter, RS Links, and RS Logics Emulator. So here basically you have to register yourself. You can see my name Rajesh Mehra is coming here. And if your name is not coming, then you have to register yourself. As I have already registered myself. So that is why this name is coming. So here you can see that it is Rockwell Automation site, and Rockwell Automation, they make software for Allen Bradley. So here you have to just type RS Logics Micro Starter and search for this software. So this window will come, and here you can see that RS Logics Micro Starter Lite download instructions. Just copy from here this Micrologics 1100. Copy this one. Go to product compatibility and downloads. And now paste. Paste here Micrologics 1100 and search for it. Select this one. Now here you have to select those softwares I told you. First is RS Logix Micro Starter Lite, RS Logic Emulator, and RS Links Classic Lite. These three softwares you need to download, and then you have to basically load these softwares on your PC in order to work on Allen Bradley PLCs. Here you can see that these three softwares are there. So last software is it is 568 MB. First one is 30.15 MB, and middle one is 8.34 MB. So these softwares you have to download. So that is why I told you these are heavy softwares. They will take some time, and they also they will take some time for loading. So here, this is the end user license. Here you can see that my information is coming, Rajesh Mehra, and I accept this agreement. Then this window will come, and here we can go for direct download. And here you can see that 3 links are there for downloading these softwares. First, second, and third, blue color. These 3 blue color links will be there. You can click these links and you can download on your PC. So here you can see that on the down window that software is showing, first one. So in this way, you can download these 3 softwares on your PC. And then you can install them easily. So this is the demo for RS Logix. Now, in this way, basically, you can download these softwares from website. Now we will go for conclusion. So here we can say that now in conclusion, movement from Industry 3.0 to Industry 4.0 means use of IoT for smart automation. PLCs were major player of Industry 3.0 and are continuing to be Industry 4.0 with addition of IoT gateways. So different softwares are available. We can use these softwares for our use. And these are some references from where we have made this PPT.